Good day, students. How are you today? Today we'll be dealing with chapter 10.2, thermal capacity, specific heat, and latent heat. Let's start the class. So let's deal with thermal capacity. By dragging the following words into the correct boxes, we'll typically want to know the definition associated with thermal capacity. The thermal capacity of an object depends on the type of material it is made up of. Metal objects heat up easily in that their thermal capacities are low. Objects made of non-metals such as wood, plastic and glass, and liquids such as water and oil have higher thermal capacities. Let's check. That is correct. Specific heat capacity. We are also to drag the following words into the correct boxes. Specific heat capacity of any substance is the energy required per kilogram and per degree Celsius to raise the temperature of a substance. It is also defined as energy required is equivalent to mass times specific heat capacity times increase in temperature. It can be written as energy is equal to mc delta T. T here represents temperature. Delta represents the difference. So when we have delta T, we have difference in temperature. C is the specific heat capacity, while M is the mass associated with that object. So we check. That's correct. So let's deal with this past question. A domestic hot water tank contains 200 kilograms of water at 20 degrees Celsius. How much energy must be supplied to heat this water at 70 degrees Celsius? So, this is what we do. We first of all write out the known before we now calculate the unknown. Here now we have that the mass to be equal to 200 kilograms, and the first temperature we can call it T initial or T1 is equal to 20 degrees Celsius, and T2, which is the T final, we have 70 degrees Celsius. So we can then calculate our difference in temperature. That will be what? T2 minus T1, 70 minus 20, all in degrees Celsius, gives 50 degrees Celsius. Don't forget that C is a constant here, not as 4,200 joule per kilogram per degree Celsius. So with that in mind, energy now is what? mc delta T. So we have mass to be 200 times C is what? 4,200 times what? 50. So let's find the answer. 2 times 50, that is what? 100. With 0 times 4,200. So with that, our answer now is 42. So we have 42 million joules. And don't forget that what? 1 million joule is equal to what? 1 megajoule. So with that, we now have, since we have 42 million joules, that's what? 42 megajoules. So let's pick 42 megajoules as we have it in the option and check. That is correct. But with that, I've made an option whereby you can study the process by which the solution was what? Calculated. So you can just observe it for some few seconds before we move on to the next phase. I think that is sufficient. Let's go on. So, meaning of specific heat. Let's start by dragging the words into the correct boxes. So, energy is needed to raise the temperature of any material. The energy is needed to increase the kinetic energy of the particles of the material. In solids, they vibrate more. In gases, they move about faster. In liquids, it is a bit of both. We can compare different materials by considering standard amounts. Let's say 1 kilogram and a standard increase in temperature, 1 degree Celsius. Different materials require different amounts of energy to raise the temperature of 1 kilogram by 1 degree Celsius. That is, they have different specific heat capacities. So we check. That is all correct. Now, the specific heat capacity of water. So, we also drag the water into the correct boxes. Water is an unusual substance. Water has a high value of specific heat capacity compared to other materials. This has important consequences. It takes a lot of energy to heat up water. Hot water takes a long time to cool down. The consequence of this can be seen in our climate. So we check. That's correct. So let's also deal with this past question, okay, and solve them and check for the answer. The specific capacity of steel is 420 joule per kilogram per Kelvin. So C that is attached to steel is what? 4,420 joule per kilogram per Kelvin. So how much energy is required to heat 1 kilogram of steel by 20 degrees centigrade? So we have mass to be 1 kilogram, and we have our T here to be what? 20 degrees centigrade. With that, you can then say that T is 20 degrees centigrade because it's going to be heated from 0 to 20. Now, energy required now will now be 1 kilogram times 420 times what? 20. And that gives us 8,400 joules. Don't forget the formula associated with this to be what? MC delta T. Now, this is the A part. For the B part, how much energy is required to heat? So the mass changes from 1 kilogram to 5 kilogram. So we still have energy equals to what? That's 5 kilogram times 420 joule per kilogram per degree centigrade times the same temperature of 20 degrees. So with that, 5 times 20 is what? 100 times 4,420. Sorry, that will be what? 42,000 joules. Don't forget that what? 1,000 joule is equal to what? 1 kilojoule. So this is equivalent to what? 42 kilojoules. And this now, 8,400 joules is equivalent to what? 8.4 kilojoule. So A is 8.4 kilojoule and B is 42 kilojoules. So I can see the option now. Let's pick it and check. That's correct. I've also made preparation for the step-by-step process by which the answers were obtained. You can check on it now in few seconds also. That is from question A and question B, as you can see. Let's move on. So let's deal with latent heat. We are also to drag the following words into the correct boxes. Let's start. Energy must be supplied to a substance to make it change state, either to boil it or melt it. This energy does not increase the substance temperature. This energy is referred to as latent heat. The energy needed to change a liquid into a gas is known as latent heat or vaporization. The energy needed to change a solid into a liquid is called the latent heat of fusion. Fusion means melting. Specific latent heat of vaporization is the energy per kilogram required to cause a substance to change from liquid to gas at its boiling point. Energy required is equal to mass times specific latent heat. So we check. That's all correct. So let's deal with latent heat again, dealing with specific latent heat of fusion and the likes. Specific latent heat of fusion is the energy per kilogram required to cause a substance to change state from solid to liquid at its melting point. How do we then measure latent heat? To determine the specific latent heat of a substance, 1 kilogram of the substance must be heated at its melting or boiling point until it changes state entirely. Specific latent heat is the energy supplied per unit mass. So we check. That's all correct. So let's deal with this question. It takes 4,500 joules to turn 2 grams of water at 100 degrees Celsius into steam. Calculate the specific latent heat of vaporization of water. So this is what happens. We have the specific latent heat to be equivalent to what? Energy per unit what? Mass. Now, the energy that is required here is what? 4,500 joules. And the mass here is what? 2.0 gram of water at 100 degrees centigrade. Here temperature is to be neglected. So don't forget that mass here is measured in kilograms, and that 1,000 gram is equivalent to what? 1 kilogram. 2.0 gram now will be what? 1 over 1,000 times 2.0 what? Kilogram. So gram will have cancelled gram, and the unit will now be in kilogram. Here I have 2 over 1,000 kilogram. With that, E is equal to 4,500 divided by 2 over what? 1,000, which is equal to 4,500 times 100 over what? 2. Then that will be equal to 2 in 4, that's 2, and 5, that's another 2, in 10, that's 5, 0, 0, 0, that is our joules. So we can then say that will now be 1, 2, 3, 4, 5. That will be 2.25 times 10 raised to power what? Times 10 raised to power 6 megajoule. Yeah, joule rather, per what? Kilogram. Don't forget that 10 raised to power 6 is what? Mega. That's megajoule per kilogram. With that, we have 2.25 megajoules per kilogram. So let's pick it and see. That's correct. So I've already provided the answer here, as you can see, and check the process also from the left hand side to the right hand side. All right. So a student wishes to calibrate a mercury in glass thermometer with a degree Celsius scale. Which values should she use for the lower fixed point and for the upper fixed point? The lower fixed point has to do with the lowest temperature that can be obtained from mercury, while the upper fixed point has to do with the temperature at which mercury does what? Boils. That is the boiling point of mercury. The lower fixed point of mercury is very, very low, in the minus range, very close to, very far away from about minus 300 degrees Celsius. So with that, if it is mercury to be used in a glass thermometer, we must make use of what? The melting point of mercury and the boiling point of mercury. Do we have it part of the option? That's correct. So with that, we choose the correct statement before we call it a day. Momentum is needed to increase the potential energy of the particles of a substance. That statement is what? False. All right. Energy is needed to increase the kinetic energy of the particles of a material. The statement is what? Correct. Because to increase the kinetic energy of the particles of a material, energy is what? Needed. Energy is needed to increase the potential energy of the molecules of a substance. The statement is false. So the second statement is correct. And yes, let's pick it and see. That is it. Now, do well to subscribe to our channel, www.edubbey.com, for more of our interactive notes and videos. Subscribe, and subscribe. Bye for now.